Is trig graphs. So last time in the video we learnt about three new trig functions, which were cosec, sec and cot, each of them being 1 over sine, cos and tan. And I did mention that they do have their own graphs, but we didn't look at it last time because that's going to be the main focus of this lesson. We're going to be plotting those graphs and then trying to remember them, and then using what we've now got to answer very similar questions to what we did when we first started meeting sine, cos and tan. So the first one we're going to look at is the sec graph, which is now on screen. We've plotted this one in degrees. We could have plotted it in radians. For now, it really doesn't make much of a difference which one we use. So on there you might be able to see a very faint orange line. That is the cos graph, and all we've done to get this thicker black line is we've done 1 divided by each of those different values. So if we start off on the y-axis, the value of cos at when x is 0 is 1, and 1 divided by 1 is still 1, so that's the same point. Then as we move along, as the x numbers increase, the value of cos x for a while decreases, and then 1 over a smaller number than 1 is going to start getting bigger and bigger and bigger. So as the orange line gets closer to 0, the black line starts getting further and further away from 0. It starts getting closer to infinity. Now when it gets to 90, the cos graph becomes 0. Cos of 90 is 0, and you can't do 1 divided by 0. It is at the moment mathematically undefined. So at this point we have an asymptote. Sometimes we show it with a dotted line. It's not on here, but there is no value for sec 90. If you try it on a calculator, it'll probably say math error because it's trying to do 1 divided by 0 and you can't do it. Just after 90 though, it's now the same idea, but what we would have for cos is a very, very, very small negative number, and 1 divided by a very, very small negative number would be a very big negative number. And then that will start decreasing in size all the way up to where the cos graph hits a minimum at 180, which then has a value of -1, and 1 over -1 is still -1. So we kind of get these repeated kind of curves, okay? The difference really here between this type of graph and the cos graph is that this graph is not a continuous curve. Because we have those asymptotes, it kind of has these jumps around about the 90 to 70 marks. Okay, now the range is similar. It says on here, it says y must be less than -1 and y must be bigger than 1 or equal to those numbers, as opposed to the cos graph, which is between those two numbers. We could still say here it still has a period of 360 degrees. It still repeats itself every 360 or 2 pi, depending on what type of unit we're using here. Okay, so that graph hopefully isn't too tricky. And because we know that the cos graph and the sine graph are pretty much the same, except for one is translated compared to the other one, it's going to be very similar when we look at this cosec graph. So we still have the same type of U shape that comes down, hits like a minimum point at 1, and then kind of tends back up towards infinity, and then has an asymptote, and then jumps across to the negative version of it. But the numbers here are slightly different. So the sine graph starts at 0, 1 divided by 0 we can't do, but 1 divided by 0.0000001 is going to be a really big number. So this graph kind of starts up towards the infinity, comes down at 90 degrees, hits a minimum at 1, and then starts curving back up towards infinity. At 180 it then jumps and does exactly the same on the negative. The properties for this one are very similar again to the previous one. It's still going to have that period of 360. It's still going to have asymptotes, but the asymptotes will be at a slightly different number. And the range again is going to be between everything that isn't between, 1 and -1. Now the cut graph kind of looks a bit like the tan graph, but backwards. So if we start at when x is 0, when x is 0, tan of 0 is 0, because it's just sine divided by cos. It's doing 0 divided by 1, which is 0. But for the cut graph, you can't do 1 divided by 0. So at that point, there is no actual answer. Again, though, if you move slightly across, it is going to have a really big answer, because tan of 0.00001 is still quite a small number, and when you do 1 divided by that, you get quite a big answer. Okay, and again, if you look on there, you can see that the tan graphs are in green, and if you do 1 over the green stuff, you get this black line that kind of, it's pretty much like a reflection of the tan graph, but it starts at a slightly different place. Now the period for this one is the same as what it is for tan. It's still just going to be 180 degrees, or pi in radians, and we have asymptotes here at 0, 180 and 360. So hopefully you get the idea of why they look like they do, and if it was an exam, you should hopefully be able to sketch what they look like, even if you have to sketch the original cos, sine and tan graphs first, and then use that to draw what the cosec, sec and cot graphs are. So we're going to be using these graphs today to solve questions very similar to when we did it in year 12 with sine, cos and tan. And all of these graphs are already drawn out for you on today's example worksheet. So here they are, all on the first page. So you've got them there as good reference. And now what we're going to do is we're going to work on these 4 examples that are on the other side of this sheet. So let's get straight into example number 1. And it says, without a calculator, find the exact values of cosec 330 in degrees, cot of 7 pi over 6, so that one's in radians, and the last one is sec of 7 pi over 4, which again is in radians. So to help us with this question, what I've got ready for us is this lovely table. So we've seen this table many times before. We've got degrees, 0, 30, 45, 60 and 90 across the top, radians along the bottom, so we can use this to help us if we've forgotten those key numbers. Don't forget, it is expected that you know this table pretty much off by heart now. It is actually in the GCSE syllabus these days, not in radians but the degrees ones, to try and remember them. Your test won't be on calculator, so you could just use your calculator, but it may be quicker if you can try and remember some of the key ones. Okay, so first one says, without a calculator, can we work out what cosec of 330 is? So we know cosec is one of a sine, so we know we're going to be using the sine graph. If we sketch a sine graph, we could work out what on the sine graph is going to be similar to 330, and we can work it out from there. So let's try and sketch badly quick. It's a bit wonky. Okay, so there's my sine graph, and what we want to work out is cosec of 330. So we want this number here. This is about 330-ish. And what we know that is this number here is going to be the same as whatever sine 30 is, except for this one would be negative. Okay, because if this was a distance of 30, this is going to be a distance of 30. It's the same type of graph, but if this is going to be a positive answer, this one's going to be a negative one. So we know that sine 30 is going to equal the same as sine 330, but this one would be negative of that. Well, using the table on the left there, we can see that sine of 30 is a half. So if this is a half, this must be minus a half. So we know sine 330 is minus a half. And now we need to work out what cosec of 330 is. Well, cosec is 1 over this. So if I do 1 over this and do 1 over of minus a half, that'll tell me what cosec 330 is. So cosec 330 is 1 over minus a half. In other words, it's the reciprocal of minus a half, which is going to be minus 2. And even though the question does say do not use a calculator, there's no reason why we can't check it on a calculator to see if we've actually got it right. Let me get myself into degrees first. So we want 1 over sine of 330, and we get minus 2. So even though it says don't use a calculator, there's no reason why we can't check with a calculator. Now if we wanted to, we could have done this question using the cosec graph. I'm quite happy at the moment to sticking with the sine graph. We know there's a connection between them. We're probably more familiar with the properties of the sine and the cos and the tan graph. So if we need to use these ones, that's fine. Okay, it makes no difference which way you do these types of question. Next one then says cot of pi over 6. Okay, so cot is 1 over tan. So let's start off by drawing the tan graph. Yeah, looks okay. So we've got, in fact, let's put them on. We've got pi over 2 here. This is pi. This is 3 pi over 2. And then we have 2 pi at the end. And we want we want 7 pi over 6. So that's a number that's just a bit bigger than pi. Okay, it's 1/6 bigger. So this one here, that's where pi over 6 is. That means it's going to say 7 pi over 6 is. If we go backwards, it's got a period of pi. So if this one here was 7 pi over 6, if we take away pi from this, we would get pi over 6. Okay, if you don't like that, you could have just done that on a calculator. So this is tan. We know tan of 7 pi over 6 is the same as tan of pi over 6. So let's write all this out. Tan of pi over 6 is the same as tan of 7 pi over 6. And if we then use the table on the left hand side of the screen, if we look at the radians and we go up to tan for pi over 6, we get 1 over root 3. So this line here is 1 over root 3. So now if I want cot of 7 pi over 6, it's going to be 1 over the tan of 7 pi over 6. So it's 1 over root 3, which is just going to be root 3. And again, we can check that on a calculator. If we do 1 over tan of 7 pi over 6, I'm in degrees, I should have changed this quickly into radians. There we go, we get at the root 3 answer that we've just worked out. And then the last one says sec of 7 pi over 4, sec being 1 over cos, so this time we need a cos graph. And we're looking for 7 pi over 4. So 7 pi over 4, if you were to write 7 pi over 4 as 1 and 3/4 pi, we can see, well, here's 1 pi, we want 3/4 of pi, so it's going to be halfway between 3 pi over 2 and 2 pi. Okay, this is where 7 pi over 4 is. We are halfway between these. That there's going to be a distance of 1/4, because if you had a quarter one, of course, you'd get 8 pi over 4, which is 2 pi. So this distance here is 1/4 of pi. So it's going to be the same height over here if I had just gone forward 1/4 of pi, or pi over 4. So what we're going to say then is cos of 7 pi over 4 is the same as cos of pi over 4. That graph clearly shows that. And if we use the table again, if we look at radians, pi over 4 and cos, we get 1 over root 2, or root 2 over 2. Depends which one you like. I think your calculator will probably give the root 2 over 2 one, because it'll probably rationalise your denominators. Let's have a check. Pi over 4, I've done inverse cos, pi over 4. So your calculator might give you root 2 over 2. That's the same as 1 over root 2. It makes no difference which one you use here. But we don't want these. We want sec. We want sec of 7 pi over 4, which is going to be 1 over cos of 7 pi over 4. It's going to be 1 over root 2, which is just going to be root 2. And again, we will check it on a calculator. 1 over cos of 7 pi over 4, and we get the root 2. So any of these where it says work it out without a calculator, this is the method you need to use, but there's no reason why you can't just use your calculator afterwards to check if you've got it right. Okay, let's try the next question. I'll keep that table on, we may need it. It says write down the periods of these functions, give your answers in terms of pi. So this is really going to test you on how good you were at your graph transformations, which is what you've done at some point with Miss Crook. So the first one says sec of 3 theta. Okay, we need to write down the period of what that is. Well, the sec graph is just like the cos graph. The cos graph has a period of 2 pi. And 3 theta means this graph is happening 3 times quicker. It is a stretch of scale factor third in the x direction. Okay, so if the original one, if sec of theta had a period of 2 pi, if we're making it 3 times quicker, that means the period is going to be 2 pi over 3. It's happening 3 times as quick, so the period is going to be a third of what it should be. For cosec of a half of pi, so half of theta, this is linked in with the sine graph. The sine graph also has a period of 2 pi, but this is a half, which means we're actually stretching it scale factor 2 in the x direction. In other words, it's going to take it twice as long to get to where we want to be compared to what it normally is. So this needs to be twice as much as well. So rather than it being 2 pi, it's going to be 2 pi times by 2. It's actually going to be 4 pi. And the last one we need to look at is 2 cot theta. Well, if it was just cot theta, which is linked in with the tan graph, that's just got a period of pi. And all this 2 does is it stretches it in the y direction. It doesn't actually affect the x direction at all. So 2 cot theta still has the same period as cot theta does. All it is, it's a stretch in the y direction. Okay, now for the next few questions, I'm going to show you a different piece of software that's going to hopefully help us. It says, sketch the graph of y equals 3 plus 5 cosec 3 theta over the interval from minus pi to pi, and then hence deduce the values of k for which there's no solutions. Now, I could try and do that on these little whiteboards and make an absolute mess of the question. Instead, I'm going to try and do it, hopefully anyway, on a website. Okay, now this website will be linked in to the description. I think I've also put it on Show My Homework for you. You may have seen it before. Let's put it on for us. It's called Desmos. It does actually have quite a nice little app. So if you want to get the app, go for it. It's free. Don't say that I'm acting on commission or anything. Anytime there's any type of graphs, if you want to just plug it onto Desmos, it makes it quite nice, and it'll maybe help visualize what you need to do for some of the other questions. Okay, so it's just desmos.com, and then all you got to do is click this big red button here that says start graphing. I do, however, already have some of these questions ready for you. Okay, now what I'm going to do is I'm going to do this the way that I would do it in an exam. Of course, you won't have this website in your exam. What you would have to do is try and build up what your graph looks like. So that's what I'm going to do. I have, though, already typed in all the different formula that I'm going to need, which are over here on the left-hand side. Okay, so because this question was talking about Cosec, I have started off with this blue graph on screen, which is just the Cosec graph. Okay, this is the 1 over sine x graph. We don't want that at all. What we want is 3 plus 5 cosec. Now I have typed it in as 1 over sine x. You can just type in cosec. I wasn't sure it worked at first, but it does work. It was just me being silly. So you don't have to type it in the way I've typed it in. You could have just gone for it as cosec x, and it would have plotted it for you. What you may have to do is on the right hand side is click the little spanner into graph settings and make sure it says radians, and where it says step on the x-axis, you might want to type it in as pi. If I just get rid of what it is without pi, you get numbers, which doesn't really help you when you're answering these questions. You can just literally type in pi and it'll change everything into lovely radians for you. So the first thing I would say in my graph, in my exam, looking at this graph, is I don't want cosec of x, I want cosec of 3x. And as we said a second ago, all that means is that this graph needs to happen 3 times quicker. Okay, so if I now click over here, that's what it looks like. So those red curves instead are the original blue curves, but as you can see, everything is happening 3 times quicker. Okay, let's get rid of the blue one then. So this is the graph we've now got. This is cosec of 3x. Again, we don't want that. We want a 5 cosec x. So what this means is we now need to stretch this red graph by a scale factor of 5 in the y direction. So if we do that, we get something that looks like this orange stuff. Okay, as you can see, all we've literally done is from the x-axis, we have stretched it in the y direction, scale factor 5. So where the minimum point was 1, that has now jumped up to 5. Okay, so this graph here, this orange graph, is the 5 cosec x, 5 cosec 3x graph. Again, that's still not what we want. We want 3 plus 5 cosec 3x. All this plus 3 does is it's going to translate the graph by 3 squares upwards. So if I click on this button, that's what's happened. All the purple graph is there is the orange graph moved 3 squares up. So in an exam, that's how I would try and build up this question. I would break it down. Even if I had to sketch 4 little graphs before I got my final answer, that would be fine. I started off with my cosec, then I went into cosec 3x, then 5 cosec 3x, and then 3 plus 5 cosec 3x. And I've got the graph that I need. Okay, now I know it says, or I think it said anyway, between minus pi, and I've gone into 2 pi's. That's fine. Doesn't really matter about that part as long as you've met at least the conditions that it says. I can zoom out a little bit, make it look even scarier for you all. So for part A, I think that's all it said we had to do. It said sketch the graph. The graph has now been sketched. Part B then says state the values for k where there are no solutions for 3 plus 5 cosec 3x. And all we need to say the answer is it's the big gap in between the minimum of the top set of curves and the maximum of the bottom ones. Okay, so if you look at the top section of the graph, each of those U-shapes have a minimum of 8. If you look at the bottom curves, each of those curves have a maximum of -2. So if you pick any number bigger than 8 or any number which is -2 or less, there will be a value for that number. Okay. What we do not have though are any possible answers, for example for 5. Okay, if you look across the y equals 5 line, in fact let me do it like this, look. Here's the y equals 5 line. That 5 line never crosses the purple line. Any purple line. If I move it up to 6, still hasn't crossed any. If I put it up to 7, it still hasn't crossed any. If I put it up to 7.9, it might look like it, but if I zoomed in, it hasn't. Okay, 8, it would touch, and as you can see, that we even put those little kind of grey dots on to say that these are intersecting now. So 8 would work. 7.9 doesn't work. Okay, so we want numbers that are less than 8, and of course if I keep going down like this, look, these are all numbers where it doesn't cross the purple until we get to this point here, which it does. So your answer for part B would be k needs to be bigger than -2. It can't equal -2 because -2 would touch the curves. K needs to be bigger than -2 but less than 8. Okay, any other numbers like 10 for example, clearly 10 has lots of solutions. Look at all them grey dots. If I went even further, like 23, again lots of dots, but any number between 8 and -2 but not including those numbers would have no solutions. Okay, I'm hoping you managed to follow that part. Oop, I've clicked on the wrong one. This is the one I want. Last question then, question 4, says sketch the graph of 1 plus 2 sec theta over the interval from -pi to 2 pi. Write down the coordinates of the points in this interval at which the gradient of the graph is 0, and therefore deduce the maximum and minimum values of 1 over 1 plus 2 sine theta and give the smallest positive values of theta at which they occur. Okay, so again we need to try and draw a graph, which I'm going to use Desmos for in a second. Then it says write down all the coordinates of the points where the interval, so where the gradient is 0, and then try and work out what the maximum and minimum points of 1 over 1 plus 2 sine theta is going to be just by looking at the graph. Now again, I think I have them all ready to go. Okay, and as you can see, this time I've actually wrote it as sec rather than 1 over cos. So here we go. This is the sec graph. Building this up in an exam, the next thing I would do would be to do the 2 sec x, so that means I need to stretch it, scale factor 2 in the y direction. Okay, so now we've got this blue line, and then what we need to do is add 1 to everything, so we're going to shuffle everything up by 1 square, and we get this green one. So there's my answer to part A. Okay, then it says write down the coordinates of where this graph has a gradient of 0. So what I'll do is, because I did this a second ago, is if I pick y equals 0, there's a gradient of 0. And all I've got to do now is work out where this black line touches our green curves. So if I put that on, for example, hopefully you can see that those dots now are showing up points on the green curve that have this gradient of 0. Okay, because don't forget I could write this as 0x minus 1, like a straight line equation, so we can kind of prove that it's got a gradient of 0. So the first coordinate on the left hand side, almost off screen there, in the range would be minus pi minus 1. And I can see another one on the right hand side there, which is pi minus 1. But there will be other places, if I was to move this line going upwards, which also have a gradient of 0. So one of the coordinates is 0, 3, and the other one is 2 pi 3. So there were 4 points on this graph where the curve has a gradient of 0. It's the maximum and minimum points of the curve. Okay, that's part B. And then part C says, using the curve 1 plus 2 sec x, could we work out where the maximum and minimum points of 1 over 1 plus 2x would actually be? Okay, so what we need to kind of think about here is, when we started this lesson and we started thinking about the sec graph, the cosec graph, and the cot graph, we were thinking about how the maximum point of the cos graph kind of relates to the minimum point of the top half of the sec graph. It's a very similar idea here. Those kind of 4 points that we just talked about a second ago when we were moving the black line up and down, the minus pi minus 1 coordinate, the 0, 3, the pi minus 1, and the 2 pi 3 coordinate, they're going to be where this next one has maximum and minimum values, because they're maximum minimums for this one. Okay, the tricky part is going to be, what's the actual new y value going to be? The x numbers won't change, so we know it's going to be at minus pi, and it's going to be at 0, and it's going to be at pi, and it's going to be at 2 pi, but the y numbers are going to slightly change. Okay, what I'm going to do is I'm just going to click this button here, and it's going to show you what the graph looks like, and then we'll talk about why it's done what it's actually done. Okay, so that's what it looks like, and as we can see, we've got these maximum and minimum points where we said. So there's a minimum point at minus pi, there's a maximum point at 0, there's another minimum at pi, and there's another maximum at 2 pi. And all we had to do to work out the new y value is take the y value of the green line and do 1 divided by it. So if we go to minus pi, the green line's y value was minus 1. We've done 1 divided by minus 1. We still get minus 1, that's why it's plotted at that point. If we look at the y value of the green line at 0, it was 3. 1 divided by 3 is a third, so that's why 0 is now at a third. And that's the same repeated at pi and at 2 pi. The question said, state the smallest positive values where these occur. So the minimum point would be the pi minus 1 coordinate, and for the maximum, 0 isn't positive, so you would have to use the 2 pi 1/3 coordinate. So your answer for part C is the minimum happens at pi minus 1 and the maximum happens at 2 pi 1/3. Okay. So those are the examples done. What you now would have to do is go away and do the 7 questions that are on the next sheet. So if we look at what they are, the first couple are identical to the first examples that we did here. There's without a calculator, work out exact values. Use the table on the left if you need to, draw some pictures. Write down the periods of the graphs. Again, it's not going to be too challenging. That's pretty much identical to the one we've done. It's question 3 onwards that you really need to kind of think about. So we've got a 5 sec x graph. Could you find the range for that? Question 4 is about 3 cot x. So these are the stretches in the y direction. If you can't think of what it looks like, use Desmos. Question 5 is a half of Cosec. Again, not too tricky. And then question 6 is where it starts building them up. Okay, if you need to use that website to help you with those, please do. And then question 7 is very similar to one that we've just done right at the end there. Hopefully that shouldn't be too much of a challenge for you to do in the remaining time of today's lesson. So I would like to see your answers for this worksheet. I will probably put my own answers up so that you can check that you are getting these correct. If you do have any issues, please send me a little message and I will try and get back to you as soon as I can. Next lesson, which is on Thursday, we are going to be doing some inverse trig. Okay, that's the arc sine stuff, and there's going to be a few more graphs that we need to kind of think about. And then next Tuesday we get on to some what we call addition formula and double angle stuff. And then in 2 weeks' time we'll be doing something called the R alpha method, which is then the last bit of trig that we have to do. So the end is in sight for trig. We've got about 2 more weeks practicing it, and then there's some like exam style questions that we get to do. And that's about it. I don't think I've got anything else to add to this video. We've talked through these examples. So yeah, any issues, send me a message. Some people still haven't submitted any work from last Tuesday or Monday's lesson, which is a bit concerning. Please just send me a message on either ShowMyHomework or Microsoft Teams. Just send me anything that you've done, just so I can tick your name off to say that you have been active. Otherwise, I do have to pass your names on, so get that done. Any issues with this worksheet, send me a message. Everything should be on ShowMyHomework on Microsoft Teams, and I will see you all on Thursday. Bye bye for now.